forgot. My other class always tells me when I'm not recording. So let's go ahead and go through this. And again, next week is class presentations. And so either Tuesday or Thursday, whatever day you signed up for. And some of you didn't tell me yet, so make sure you tell me today before you leave. All right, question number one actually is a pretty tough question. It is going back to the first thing I did. I'm the redox in that very first video. Beryllium is a +2, and we know that your periodic table, you got to have it in front of you. This is chemistry. So beryllium is a +2. And so we're building on everything we have been, right? If you can't do the naming, you can't do the charges, then you're not going to be able to do the oxidation number. That means the chlorine is -1. So in this case, it is a simple ionic compound. So our oxidation numbers were just the charges. So that one's pretty straightforward. The oxidation number is for each atom of the chlorine. So it is just -1. All right, on this one, when you have two nonmetals, the greedier one gets its oxidation number, its common charge. So oxygen in here, pretty much, it's always going to have a -2. It's rare exceptions when it doesn't. Of course, when it's by itself, it gets the halo. And the one demo I did in one of the videos, which is why peroxide works so well, if it's -2, then the chlorine is going to have to take the positive. So one of them has to always be positive. Oxidation numbers, we always show the charge. Some of you can see it's a swapping, so it ends up as a +7, which is insane. Or you can go through the math. I recommend, having done this with my other class, that you do it the way that I show it in the video, where you show your oxidation numbers above. What people were doing is they start taking shortcuts and they do their oxidation numbers and their math above, and then they don't know which number is what. And so keeping it clearly separated, doing your math below if you need to. So -2 times 7 is -14. That means I need a +14 to balance negative, and then we would divide it by the chlorine. So divided by the 2 chlorines in the compound, each chlorine is a +7. That is an insane number. Students are always like, it doesn't make sense. Chlorine wants to be a -1. Why would it be a +7? This is a man-made compound, and it tells a chemist this is going to be extremely reactive. I don't know why anybody would make it. They probably hypothesized, oh, well, if we make chlorine lose 7, it would drop back like neon and make it stable. I don't know, but that number is large. When you see huge oxidation numbers, it means there's going to be a chemical reaction. All right, on this one, fluorine gets to be -1. It is the greediest of them all. It's going to be a -1 unless it's by itself. That means I have -4. And the one thing with this one, when you add it up, you're not balancing to get to 0 because there is a charge. So when you add up, the chlorine has to be a +5, so that when you add up all your oxidation numbers of each atom that is present, your sum ends up as a +1. That gives the chlorine a +5. Again, this is a man-made compound. No idea why they would try to make it, but that's what you end up with. All right, oxygen gets to be the -2. You see oxygen in a compound, it's going to be your -2. That gives us -4. And again, like the last one, you are not adding up to get to 0. You're going to end up with the charge, which is -1. That means the chlorine has to be +3, so our sum is -1. And yeah, this is chlorite, and that's kind of what it means to be an ite. All right, the last one, barium, is in the 2A's on our periodic table. Oxygen is going to get to be the -2. Now we have to do some math. So the barium's a +2. This is the monkey in the middle. And I do have my monkey is hanging up there. I found him. So to find the chlorine, the oxygen, there's 2 oxygens. times -2 gives me -4. So there's no charge shown on this compound. So overall, we're going to end up at 0. That means this has to be a +2 also. So when I add these all up, I end up at 0. That is not oxygen. I'm sorry, that's not chlorine's number, because this parentheses mean that we double. We have 2 oxygens and 2 chlorines. So I have to divide by my 2 chlorines. So each chlorine is a +1. That is the difference between a hypochlorite and a chlorite. So the ites have oxidation number of a +3. The hypo, its oxidation number actually is going down. So when I taught it, I said it means below as far as the number of oxygens. It actually means below as far as the oxidation number also. All right, any questions? So here we're classifying. These classifications are not the only classifications. If I'm asking you to classify, though, they do fall into it. On question number 3, I did not ask you to classify because not all of them fell into our classifications. So like X, this does not fall into one of our classifications because multiple things are going on here. So please realize that these are not the only classifications, but the first 2 are combos. And that is because there's only one product. So you're combining them, bringing them together into one. C is a single. D is a double. And then E is a decomp. And then I asked you to circle the redox reactions. If you have a halo, like in A, the oxygen's a halo. On C, we have the zinc and the silver. So if they're by themselves, do the halo. And you can sing. And then in E, we have a halo. So the halos, over our redox, we get to circle them. Doubles, they're never. Those are the blue ox. And actually, I mentioned this, but that's why I have this question on the study set. Singles and combustions are always going to be oxidation reductions. Doubles are never. Combos and decomps are usually, but not always. And so here's an example where we have a combo and it's not an oxidation reduction. All right, the next one. Halos by themselves. That's really, I don't like the word trick, but that's the trick to doing these. And then in the compound, they are just their charges. So the coefficients have no impact on our Leo-Ger part, so you kind of ignore them at this point. I like to do the acronym again, Leo-Ger. So Leo means we lost electrons, and that is what is oxidized. And it's always reading forward in the equation. The aluminum is +3 means it lost electrons. The chlorine Ger means it gained electrons. And that is what is reduced, or it went through reduction. So the chlorine ends up in a reduced state. I'm going to go ahead and do my OA and RA at the same time. So I always write the O's on top and I crisscross. The crisscross means I don't write anything in the middle. You're going to be, like we do on the back, filling in on the second page, filling in a box at the bottom with all the parts. So when we get to that, we'll see. But what I find is most students get the Leo-Ger part, and so it's a wonderful acronym. They always switch. The OA is the oxidizing agent. It causes oxidation. So the oxidizing agent causes oxidation, meaning it's going to gain an electron, which means it goes through reduction. The other thing about the OA and the RA is they must be a reactant. So however it started, so you want to write it as Cl2 because it starts as Cl2. The reducing agent is the aluminum. It just takes practice. Having done this for a long, long time, and just looking at the results from all of you, the students who put the time in and practiced it, they got it. And the good news is you can move on to today's stuff and then come back and get this. And yeah, so I would use your time wisely. And all right, the zeros, find your halos. So the zinc and the copper are 0. In the compounds, because the chlorine is a -1, the zinc and the copper are +2s. So it is a Leo Ger. The zinc is losing. That's what the +2 means. And the copper is gaining because it's going from a +2 back to 0. So it's getting back its electrons. So the oxidizing agent is not copper, it is the copper chloride. Reactants are caused, right, the reducing agent would just be the zinc. Something else that's missing from all these equations, and I mentioned it, is states of matter. We're not going to show states of matter. In 221, we do start showing them. All right, the other thing I didn't ask for, as I mentioned, is classifying, but the first one you could classify. It does fall under a combo, just a metal, non-metal will combine. There are other types of combinations. All right, this is a single. So if you did classify those two, you could definitely classify as a combo and a single. On E, classifying, it doesn't fall into one of our classifications. The closest we could put is combustion. So I'm going to put that as a parentheses. I would not ask you to do that, because one of the things I said with combustions is we're going to end up with the CO2 and the H2O. So some people will say combustion is specifically of a carbon-hydrogen compound. But combustion does mean to burn, and that's what's happening here. So plus oxygen means to burn. Oxygen ending up in the compounds is ending at -2. So oxygen is gaining electrons. I like to put an X through my oxygen just so you don't think it's a 0. That means my oxidizing agent is the O2. Combustion, that's actually where all this terminology comes from. Combustion means oxygen comes out like that. Your nickel is partnered with a non-metal each time, and so the nickel is always a +2, so nothing happened. It's a spectator. It's just along for the show. Sulfur starts as a -2. It ends up combined with the oxygen. If the oxygen's negative, the sulfur has to take one for the team, and it's going to be positive. And so the sulfur is my Leo. My reducing agent is the nickel sulfide. This is the whole compound. And again, it's okay if you're not perfect. In fact, when people turn in perfect study sets with no marks on them, I know they just copied everything. Yeah. All right. On the next one, it doesn't fall into any of our classifications, so we're not going to even try. Sulfur has a halo, so we know we're doing Leo Ger. Hydrogen, whenever hydrogen, this is that first video from last week, whenever hydrogen is in a compound, it takes the +1. It's why we show it with the 1As, because it will be a +1 in a compound. I do want to make a quick comment. It's not an always, but it is an always for this class. When you move on to 221, sometimes some teachers will throw in trick questions. There's man-made compounds where hydrogen gets to be a -1, but in our class, it's going to be a +1 whenever it's in a compound. So nothing happens to the hydrogen. Also, oxygen is going to be a -2 when it's in a compound. So nothing happens to the oxygen. Sulfur, when it's with the hydrogen, it's -2, and it ends up at 0. So there is something else you can do with Leo Ger. Some students can see the losing and gaining. For some students, it's really helpful to just look at how the oxidation number changes as you move forward in the equation. The sulfur is going from a -2 to a 0. So it's like a thermometer. It's rising up on the oxidation number scale. So Leo's oxidation number always moves up, which is the sulfur. It is the nitrogen then that must be the gaining. So we can actually finish this chart. We can do everything without doing nitrogen's oxidation number. And I hesitate whether I should do it because I want to point out, because when you get to the celebration in 2 weeks, for some of you, you get done in an hour, which is what it would have been in class. And some of you, if you don't put the time in and you're trying to Google everything, you're not going to get done. You're not going to do well. You don't need every oxidation number to figure this out. If you have a question where I specifically say, give me the oxidation number, then yeah, you have to figure it out. But the nitrogen starts as HNO3, so that is my oxidizing agent. The sulfur starts as H2S, that's my reducing agent. If you did oxidation numbers, the nitrogen here is a +2 because it has to balance the oxygen. And then over here to balance all 3 of those oxygens, that gives us a -6. This would be a +5. So the 1 and the 5 would give us +6 to balance the oxygens. So its oxidation state is going from a 5 down to a 2. And so that's because it's gaining electrons. So nitrogen goes through reduction. Again, oxidation reduction is an element. That's why I always say what element changed. There is a possibility, and this is very rare, that one element can go through both oxidation and reduction. I try, in the 200 level, we'll see an example. Yeah, you can also have, I know this shows up in the 221 because my son had asked me, he's like, that can happen. You can actually have 2 things go through oxidation, but you can never have an oxidation without a reduction. So if something's oxidized, even if 2 things are oxidized, something has to be reduced. Because for something to lose electrons, something has to gain electrons. So you always have to have a Leo and a Gur. All right, on this one, find your halos by themselves, give them their little halos. In the compound, they have to balance the oxygen, so the iron's a 2, +2. And here with the 2, 3, the antimony must have started at a +3. This is a single, because you have a single on each side. Sorry about that. Leo Gur, the iron is my Leo, the antimony is my Gur. And your oxidizing agent is the antimony 3 oxide. The reducing agent is the iron. So that's questions 3 and 4. The study set, your study sets are really good study sets, because the person who's writing your celebrations also wrote your study sets. So even if you did it, you're going to want to print it again for good practice for 2 weeks from now. All right, this one, we have ammonia, which is NH3. You didn't have to show states of matter, but I'm going to just for the heck of it. If you see these show up, you know what? They show up today in our notes. And yeah. So produce means arrow. Nitrous oxide, which I gave you up here, is N2O, which is a gas, and water. And when water is written as water, that would be a liquid. So these are states of matter. Again, we're not going to worry about them. They don't matter in this class for now. In 221 and 222, they are very important. We work with them. All right, we do need to balance our equation because there are 2 nitrogens there. So put a 2. Again, this is, if we tried to classify it, it would be a type of combustion, but it's not a pure combustion. That gives me 2 nitrogens, that gives me 6 hydrogens, so we put a 3 here. And now the oxygens. I have 3 from the waters plus 1 more. So to get 4 oxygens, I'm going to have 2 O2s. So 2, 2, 1, 3. I don't show the 1, but you can. I'll talk about that more when we get to the math today. We have a halo, so we get to do the Leo Gur. And again, the videos and having watched my other class, and those of you who put the time in, just put the time in. You all can get this. But there are 4 videos because this is, I spend a lot of time putting them together and writing those handouts for you. So just put the time in. Oxygen in the compounds is a -2. So the oxygen is gaining electron. Its oxidation number is going down. My hydrogen is in a compound everywhere. So it's not the hydrogen. Hydrogen just switch partners. It's perfectly compliant to do that. The nitrogen is going to balance out whatever you have. So here it's just a +1. Each nitrogen's a +1. So it's losing electrons as the oxygen's so greedy, it's taking the electrons. That would mean my NH3 is my oxidizing, I'm sorry, my NH3 is my reducing agent. And then my oxidizing agent, of course, is the oxygen. All right, any questions from the first page? And again, I'll scan this and get it posted. Today's up eventually. All right. And let's do this second page. So iron and means plus chlorine. So just find the words you need. Iron plus chlorine. Chlorine is one of the diatomics. So they make that 7, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So first question on the second page of your lab, when they are by themselves, you always have 2. It's like O2. You've been writing O2 as O2. Nobody ever questions that. All right, on this one, I had to tell you what it makes. So react means arrow. I had to tell you what it makes because the iron can be multiple charges. It's in that variable zone of different charges. Yeah, chlorine's a -1. This is all going back to naming. And so we need subscripts first. So make a note to yourself, subscripts first. The subscripts come from either being a diatomic or charges. So you do that first, figuring that out, and then you balance. So once you have all the subscripts, you don't have to put the blanks, but the students who do tend to do really good. We have a 2 and a 3, so 2 FeCl3s. So we need a 2 in front of this iron, so 2, 3, 2. And let's go ahead and do our Leo Gur because we have halos. So the 2 biggest mistakes made on this question, forgetting the diatomic and not putting halos. That students see the iron 3 here and they just make this an iron 3. It's only when it's in a compound that it has the oxidation number by themselves. Do the halo, do your make yourself joyous. That's what it's all about. So the iron +3 means it lost. Chlorine gained. My oxidizing agent is going to be my chlorine. My reducing agent is the iron. I just figured this out and then I'll go down here and do my chart at the end. All right, highlight or underline. Neutralize means plus. This means it reacts. So aluminum hydroxide. Remember those polyatomics? You don't need that huge list. You just need this simple list. So hydroxide is OH. And it has -1, and the aluminum's a +3 because aluminum needs to drop 3 to get to neon. It's all the stuff we did. It comes back together. So aluminum hydroxide, neutralize means plus. Hydro in hydrochloric means there's no oxygen. So it's just HCl. In fact, you all knew that before you started taking this class probably, and then you just start changing rules for some reason. You make chemistry harder than it is. And so don't. It's very methodical. You just have to take the time to do it and then do it again. All right. Because these charges are the same, I don't need subscripts. Now, when we did naming, I did comment many times that your final answer does not show charges. And I've also commented many times in the past week that I am okay in the balance equations if you show your charges, if they're up above, they're not down in the formula, that everything's nice and neat and we can follow the work systematically. Again, a lot of you switch teachers next term. When you go to the 200 chemistry, do how that teacher wants it. All right, this is a double. This first one was a combo. And I recognize that because they each have a partner, so they switch your partners. The aluminum is going to go with the chlorine. They keep their charges, so we'll need a subscript there. The hydrogen goes with the hydroxide. So you get HOH, which is perfectly fine to write it like that. I actually write it like that. That is water, H2O. So you can write it as HOH, or you can write it as H2O. It's a preference. Half of you will write it one way, half the other way. Do not write it as HOH3, because that is just wrong. That does not exist. We have to balance. There's 3 OHs, so we're going to need 3 here, whichever way you write it, as 3 waters or 3. And then we have 3 hydrogens and 3 chlorines, so we'll need a 3 there. Doubles are blue ox, so we're not a redox. We're not going to do Leoger, which is good because I wrote really large over it. All right, we're going to mix. So metallic aluminum means just aluminum. It means it has a halo. With means plus. And then copper 2, nitrate. Nitrate is Nick. Nick shows up a lot. You need to know your polyatomics. You want to have them handy. This is a single. We have an element plus a compound. If you do the practice, go back and redo the lab from last week, go back and redo all this stuff, you're going to have it. You're not going to need any notes. But writing out notes means just keep doing your practice. So we're not going to put metals together. The aluminum is now with the nitrate. The nitrate, Nick, is still -1. And we talked about it here. Aluminum likes the 3, so aluminum nitrate. Copper is by itself. It gets a halo. Before you do the Leoger, make sure you balance your equations. So before you turn in your quiz today, so please do the quiz, is make sure you balance. So my nitrates did change, so I need to get to 6 of them. That puts a 2 in front of the aluminum and a 3 in front of the copper. Probably the most asked question with this one is somebody will say, well, I wrote it as 3 coppers plus 2 aluminum nitrates. Is that okay? And absolutely. It doesn't matter the order you write them in. It does matter that you put the aluminum with the nitrate, putting the aluminum first. All right, this is a Leoger. Let's write really small. The aluminum is your Leo, and the copper is your Ger. Your oxidizing agent is the copper nitrate. And your reducing agent is the aluminum. So again, this is just a teaching tool. I always have to figure this out to do my chart. I'm amazed at those of you who don't do any kind of little thing. All right, this is combustion. And so we're going to do C4H10 plus oxygen is what combustion means. And we get CO2 and H2O. So combustions are your friends because it's always plus oxygen and you always get CO2 and H2O. The hardest piece with this, and we will get to do Leo-Gur, is the balancing, because you do get large numbers. So the carbon becomes CO2, the hydrogens become H2O, and when you go back to do the oxygen, you have 8 plus 5. So for the oxygen, I have 4 times 2, which is 8 plus 5 more. So I have 13. So on combustions only, you have a choice. I am okay with you doing fractions. My son's teacher commented apparently that he hates fractions. I had a wonderful 3rd and 4th grade teachers, and so I love fractions. Decimals are the same thing. Or you can recognize this is where I have to double. So this becomes a 2, this will become a 13, this will become an 8, and this will become a 10. All right, Leo-Gur, oxygen gains, carbon loses. Oxygen's going from a 0 to a -2. So it is my oxidizing agent, and my reducing agent is the C, not C, it's C4H10. It's the whole compound. We're good, we can move on. You don't have to do all the oxidation numbers. I'm going to do it just to point out as practice, because that's what we're doing. The hydrogen stays as a +1. So hydrogen didn't change, that's why it's not my answer. So the only thing we're left with is the carbon. CO2 makes sense because the carbon's a +4. What doesn't make sense is this one, and I think I did this one before. You end up, when you take the -10 and divide by the 4 carbons, you do end up with a fractional state, so -2.5. Oxidation numbers are not charges, they are a potential for reaction. And so the carbon changed. That is why you can get fractions, you can get anything's possible. Except for hydrogen. Hydrogen's +1 in the compound. All right, last one is a decomp, and these I will tell you what's going on. So we see Nic again, nitrate. It's going to break apart. That's decompose, break down means decompose. Lead 2 oxide. So the lead is still +2. When we do Leo-Gur, it's not going to be Leo or Gur. Nitrogen dioxide is NO2. That's why we did all the naming stuff, so you could read the language of chemistry. And oxygen gas means O2. We have a halo, so we're going to do Leo-Gur. So this is the problem, the students get so excited. They're like, okay, I'm going to do my Leo-Gur. Oxygen's starting out, this -1 was so we could balance. When you go back to oxidation numbers, the oxygen is -2. So oxygen is actually losing. So it's going from a -2 up to a 0. Not all the oxygen changed. PB doesn't change, so the nitrogen must be what's gaining, and it does. It's a +5 to a +4. You can come to office hours. I do have office hours this evening from 6 to 7:30, and then next week I'll have all my regular office hours, and again on Tuesday I'll have extra ones after the class presentations, from noon till 1 or 2. I can stay as long as somebody needs help. The OA and RA, the same thing. This is the double agent, and the decomp, whatever you start with is both. So I made a mistake. I did it on purpose because it's really common. What's my mistake? If anybody's there. So
I'm here, but you lost me.
Oh, thanks, Stephen. All right, somebody's there. That makes it worthwhile. The mistake I made was I was so excited to do Leo-Gur because I understand it, and actually most students do really good with Leo-Gur. I forgot to balance my equation. So make sure I usually put a note at the bottom that says, did you remember to go balance it? I started doing that because so many people forget to balance at some point. So make sure you balanced all your equations. I know that this one, it doesn't work out. If you're having trouble getting it to work out, go back and start with a 2. If you have to go up to a 3 or a 4, you're overdoing it. So I'm not going to give you ones that are that crazy. This is an intro chemistry class. So this 2 is going to give me 2 PBs. I have 2 nitrogens times 2. So this parentheses, I have 2 and 2. I'm going to need 4 there. And then this is where you say a prayer, a blessing, and you hope the oxygen worked out. We have 6 times 2, which is 12 oxygens. I have 2. I have 8. That's 10. I have 2 more. We're good. So this would be if I asked what are the coefficients, 2, 2, 4, and 1. So the coefficient. This is actually, for some of you on your lab, I wrote a note back to you. You overbalance, like you went up to 4, 4, 8, and 2. So we want the lowest whole number coefficients. All right, now we have to fill a chart in. And there were 1 or 2 of you who had all this on your lab. You had everything correct up there, and then you did something funky on the chart. And so I wrote a note to you. So if you did turn in your lab by Saturday and you got like less than a 13, you can fix the things that I commented, and you do get to resubmit. If you didn't do your lab, I do it, but I would move on and come back, or I don't know, just do it. You do get until the celebration, but finals week starts getting funky because all your classes start having stuff. All right, so type. These are our 5 types of reactions. Move that up. And the double is the no. The rest are yes. So there's no more answers. If it's a no, it's just cross it out. Again, don't write not applicable. The rest, so Leo is what's oxidized. That's what Leo means, losing electrons oxidized. So iron. Gur is what's reduced, so chlorine. And then what's reduced is our oxidizing agent. Make sure you read my columns, because sometimes I change which piece I'm asking for. So do your Leo Gur and then find what piece we want. All right, for the single, we got aluminum, we got copper, and then we have the copper nitrate. So you do need to write the full compound for the oxidizing agent. Combustion is a yes. So carbon, oxygen, O2, and then the decomp. So these are all, it is the oxygen, the nitrogen, and then the PB and O3. And questions. Now, if we were in a full class, we would have 3 hours. And at this point, I would put practice on the board and I would come around and help you. And then we would do the stoichiometry. But so you'll have to find the time to practice. And if you have questions, come to my office hours this evening. And I'm more than willing to look at your quiz and to give you feedback before you submit it. But you can do this. You can all do this. I'm going to stop my video and start the next one.